Is my dots and boxes game. I made it a text interface. So it asks you what size board you want, the number of plies, and who you would like to go first. So here is what it looks like. This is how you determine which column you're going to go in, which row you're going to go in, and here's the key. So if I go row 0, column 1, that's where I put it, and the AI chose to go in row 2, column 3. We can just keep going with this. So the AI clearly beat me there. So the way I chose to model this, so here's the main app, which kind of handles the input. I set up a new game. Then the game constructor just adds the players to the list of players, and then goes over each player and displays the board, and then has them all take a turn. So I use an interface for the players, so the AI player and the human player could, have some type of definition for what methods that they need. So the human players take a turn is just kind of what you saw, asking where I'd like to draw the line and returning it. And then there's a method for claiming the box, which updates the score. The AI player is a bit more involved since it actually implements Minimax. But before I go into that, I also wanted to go into the board itself. So the board is modeled with a hash map of boxes and a hash map of the matrix. So I use the point class to determine where any object on the matrix is, and then I created my own box class. So drawing a line is just a matter of, replacing this integer value from -1, which means it's empty, um, to whatever the token is for the player, which you can see somewhere else. So that is the abstract class. The game board is different from the board search node because I wanted the board that the AI was searching with to be completely separate from the game board so it doesn't affect the actual play. So the game board is pretty simple. There's a bunch of displays. Um, and the search node board is pretty similar, except it has this get successors function, it has the evaluation function, and then it keeps track of the heuristic and the children. So getting into the AI player, the AI player clears out their possible moves, sets the origin board, which is the board that is currently the game state, and evaluates Minimax. So for Minimax, I am checking the terminal state of if the depth is at the number of plies that the human gave at the beginning, or if there are not any other moves. I am evaluating the root board with the evaluate node function that I just showed earlier, and then I'm setting the heuristic to that root board. Another little thing I wanted to do is that since I'm using recursion here, I wanted to keep track of all of the AI's next available moves and add that node to the proper place. So if there's a series of moves that all evaluate to 0, I want a list of all those moves. That way I could pick one at random instead of only picking the most recently evaluated move. So if the player is if I'm playing as a maximizing player, which is always the AI in this case, I'm getting the successors, I'm going through each of the children, then I'm taking the maximum of either the value originally set to -1,000 or the mini max of that child. And so the recursion kind of takes play here until we set the heuristic or return the value. And a similar thing happening with minimizing player choices. Yeah, so that is it. There's some utility stuff here, just determining if I'm looking at a horizontal line, a vertical line, a dot, or a box center. The boxes themselves have owner tokens, they have a location, and I'm setting all the edges to blank, and then I have a function here to determine if they're complete. So if a box is completed, we're basically going through and having the player claim that box.